Hi, I'm Paige, and this is our Fed Day project. It is multi-use hook. For our design cycle, we initially asked what we could be using on vacation. So specifically, we went for a camping trip, and we decided to come up with like a multi-tool type object that is a hook that has multiple tie-off points and is designed structurally to handle the stress of holding heavy objects. We then went and created several different CAD designs and then landed on a final iteration that we then chose to print in the Hill Makerspace. And initially, when printing, the print failed due to using the wrong filament, and the printer also ran out of filament, so that killed our first print. And our second print was successful, and that's what we've done all of our stress testing on. It ended up breaking due to a force that torqued it, and it snapped right along the print line. So we found a weak point there in our design and decided to reprint with a thicker infill so that we don't have that same issue. Though we did use undue stress when testing and during that specific test.
All right, hey, I'm Josh. And just to expound a little bit on that creative process that Paige was enlightening us on, I just wanted to provide some visual aid for you. As for the inspiration for our project, we looked up multiple small plastic tools that we could possibly 3D print. Each one had its own uniqueness that we tried to incorporate into the final product. And you can see some of the capabilities that you'll see here that will also be seen in our device, such as the hooking and being able to hang. And here are some preliminary drawings we had of that final design. We had about three-ish really big variances, but we ended up deciding on this one here. And then we used that to create the first print with the makerspace at the Hill Library right here. And we were really proud of what we had. It had all of the functions that we desired, with the holes here that paracord could be looped through, and then the hook to be placed on another object. And unfortunately, editing.
So there is definitely room for improvement with this product. As you can see, it did fracture and break due to a stress test, but the nature of this stress test would not be applicable to the actual product because it was too heavy, and you wouldn't use something that heavy in the nature of this product's use. Here you can see the nature at which it's meant to be used. We can tie off multiple points with many of the holes in the center body. We can hang stuff off of the bottom. We can use the hook to hang vertically, upside down, whatever you name it. And in the next slide, you'll see the videos we did to test this product. In the first one, it's just this. This is the only point with stress on it. We lift up a relatively heavy book bag, about 15 to 20 pounds. The book bag in the second video is roughly the same weight, but there's 2 points of stress, so the hook and the bottom hook. As you can see, it did perform the task it needed to with relative ease. We didn't feel like it was about to break or fracture like it did on the test that did break it, but it did pass those tests.
My name is Nathan, and I wanted to thank my project mates that they did a great job of presenting our project, and I wanted to close off on things that could help future students doing a similar project or something that can be used to 3D print. First, establish precise project specifications from the beginning. This is getting all your planning out the way, getting your team schedule, everything. Next would be to have an encouraging environment for self-improvement and self-motivation. This project can take a very long time, a couple months in fact. So sometimes you might get bored in the middle. So make sure you want to keep everything flowing, everything good, keep your ideas fresh. Next is to create milestones. So just like in the planning phase, you want to create milestones and goals that you can work towards. This is also a motivator because if you have a certain due date, you know you got to get it done at this specific time so you can stay on track and make sure your group mates stay on track as well. Next, we'll break every step of your project down for analysis to see any problems. This is including planning for plausible flaws that you can see in maybe your design or also in testing your prototypes. So you can maybe see some stress points or see certain things, maybe this is too thin, this is too thick, things like that. Also, expect the unexpected. At any stage of your project, you can have setbacks that can be minor or catastrophic. Something like your prototype not working, that you may have to do a complete redesign, or something that you can break during your final testing, like we did. Finally, we say do your most strenuous test last. So to find the maximum limit of your project to best see what the best next course of action is. And these are our sources. Thank you.